This video is going to be all about a single price monopoly, and this is our first introduction into a market structure graph for what a firm is going to look like. So with a monopoly, the firm is the market, so they're the only producer with no close substitutes. So one of the odd-off questions is that monopolies do not have a supply curve, and the reason for that is the firm being the only producer. The supply curve is a relationship of what firms are willing and able to produce at different prices and quantities. However, being the only firm with no competition means that the firm gets to charge and produce whatever they want to some degree. So they're able to produce the quantity that maximizes profit. So the relationship is simply they're only willing to produce the quantity at the price that maximizes their profit. So there's no supply curve because there's just that one quantity they're willing to produce, not a relationship of various prices and quantities. So on the revenue side, what I want to first do is talk about, well, why is the marginal revenue curve less than the firm's demand curve? So if we were to label out a demand curve, we end up with, let's say, and I'm going to use some numbers. So $10, let's say, we get one person to buy it. And because the firm does face a downward sloping demand curve, in order to sell more, they have to lower the price. So at $9, they get 2 people to buy it, and then let's say we'll just stop at $8 and say 3 people buy it. So the idea, at least the start of my demand curve is, well, 10 and 1, 9 and 2, 8 and 3. So there's kind of like my demand curve. Now, we usually say that the firm, or this curve that's equal to the demand, is always equal to the price, right? The price is 10. The average revenue is also going to be that curve as well. So 10 divided by 1, we'll get to that when we get to total revenue. And the firm's demand curve, which is what we started drawing anyway. So we end up with this relationship. 1, 2, 3. So since total revenue is price times quantity, we just simply take 10 times 1, 9 times 2, and 8 times 3. So there's my total revenue curve. And if I were to take this and I wanted to find the average revenue, so why is price equal to average revenue equals demand? 10 divided by the quantity 1 is 10, so that's the price. 18 divided by 2 is 9. So that's the average revenue, right? Total revenue divided by the quantity. 24 divided by 3 gives you that 8. So the average revenue is equal to that price and demand always. Regardless of what market structure we're talking about, price always equals average revenue equals demand. Now, from the MR standpoint, we've done a lot with marginal in the last unit in terms of marginal cost, marginal product. So marginal revenue is simply the change in total revenue. So when we sell 0 units, we get 0 revenue. So the first change in revenue is 10. As when we sell the first one, we make $10 more than selling 0 units. So where MR and parties start are equal. And then they get to diverge from there. So they never cross over. With the second unit, then, we're able to make 8 more. So then marginal revenue becomes 8, which then drops below my demand curve, which is at 9. Then when we sell the next unit, we end up with $6 more, and so 3 and 6 would be somewhere here. And so we end up with an MR curve that is less than demand. And the full reason why is when the firm lowers the price, it's not just lowering the price for that next consumer, they're lowering that price for all consumers. So when the firm lowers it from 9 to 8, that third person doesn't just pay 8, everybody pays 8. So that price decrease refers to the change of the price for everybody, not just that last consumer. As we draw a single price monopoly, I always start with the Mr. and party curves. So I draw my downward sloping demand, which equals average revenue equals the price. My MR curve drops below that. Then I end up drawing my marginal cost curve. So there's my marginal cost curve. So now I can find, with these three curves, I can find the quantity that maximizes profit. So profit is usually listed as pi. So our profit max rule is whenever the marginal revenue equals the marginal cost. So as the firm produces more and more units, the marginal revenue of producing all these units is greater than the cost it's going to be to produce that next unit. So all of these units are profitable up until they're equal each other at this point. And so I'm just going to label that as Q star. That's the quantity the firm will produce. Then if I go up, because the price doesn't simply just get dragged across, I have to go to my price curve at that quantity in order to find out that this is the price the monopolist would charge. So they're going to charge this price and make this many units. Now with these three curves, the other intersection is also important. That's our allocatively efficient. So my allocatively efficient point is where the MC, the marginal cost of producing it, is equal to what people are willing and able to pay for that, my price. So the fact that marginal cost equals price gives us, this would be my allocatively efficient or my socially optimal, and then this would be my socially optimal price. So what society kind of wants it to charge. So if you remember back to our externality unit, the idea that society in this case is going to want more than the market produces, so that creates this deadweight loss between the quantity the market produces, Q star, and the socially optimal point, that red dot there. So there's my deadweight loss involved if the monopolist is just profit maximizing. Then as I draw in my average total cost curve, and let's say this firm's earning a profit, so here's my average cost, with its minimum being at marginal cost, because the marginal pulls the average total cost down and then up. Then I can look at two other points of interest. So we have this point first, which is when MC equals ATC, which is at minimum ATC. That's what we came to know as productive efficiency. So from the producer's standpoint, they want to lower their average total cost, and so there's my level of productive efficiency. The other point is here, when the price equals the average total cost. When that happens, that price and quantity is going to be where the firm breaks even, often called the fair return pricing. So the firm's not going to earn a profit. They're not going to lose money. They're just simply going to break even. So that's another way. We'll get into the actual regulation idea, but these points are going to be important to know as we go through. The last point I want to make here, the other intersection kind of point. First off, like MC equals 8, or this point won't matter at all. So it doesn't matter where ATC hits the MR curve. That's not going to matter. The MR equals 0. That is where the firm is going to maximize revenue, so revenue maximizing. And that happens because in all of this range of the MR curve, it's positive. So with each additional unit that's sold, we're adding to total revenue because marginal revenue is positive. So the next unit earns me $10, and then 9, and then 8, and then 7, and then 3, and then 1, and then 0 to revenue. And if I keep producing down the MR curve, which can go negative, every unit I sell is losing me revenue. And so that ends up total revenues falling. So as we look at this single price monopolist, we are going to look at the areas on the graph a bit. So I have my single price monopolist, the MR and party curve being separate, MC and ATC are drawn in. So the firm is going to produce at the profit max, which is here, MR equals MC. We're going to go up to the price curve to get the price the monopolist is going to charge. And right here is where we have some nice pieces in place, or some nice areas that are already there for us. We have this deadweight loss triangle, the quantity that's produced versus the socially efficient, MC equals price. So this is my deadweight loss. Then we also have my consumer surplus, which is above the price, below the demand curve. So all of that area is consumer surplus. Because people are willing to pay more but don't have to, they get to pay P star. Then the area below that curve becomes total revenue. right? Total revenue equals price times quantity. So here's my price, 0 to P star. 0 to Q star is my quantity. So this rectangle becomes total revenue. Now, to figure out profitability at this quantity, and in this case, this is the only quantity we care about, a Q star. We're going to go up just like we did for the price and come across. But we're going to do the same thing for average total cost. So as we move up this quantity, which is, so not like here, not anywhere else, just this quantity, this is where it hits ATC. So we are going to put a nice little dot, make it easy for the grader, and pull that across. So there's my average total cost. So as we look at profit as being total revenue minus total cost, we have total revenue labeled in red. Now we're going to do total cost, which is equal to, or can be found by, taking the average cost of producing times how many quantity I'm making. So this 0 to ATC, 0 to Q star. Here's my total cost box. And so the difference, subtraction, between total revenue, the red and the blue, being total cost, is my profit. And so that profit becomes this area here. That difference in red and blue, total revenue minus total cost. So in this case, because revenue is larger, this firm is earning a profit. And that's how we would find kind of all these various areas on this graph.